Welcome to 1102, Introduction to Problem Solving. To start the semester, we're going to look at some basics of a program called MATLAB, which can help you in solving problems as you move through your engineering career. In particular, in this lecture, we're going to look at some variable basics in MATLAB and some types of numeric data you can have, including scalars and vectors. So what is MATLAB? MATLAB is basically a program that allows you to manipulate code to your advantage to solve problems. So learning a program language is like learning to speak a foreign language. It's not going to be easy right away. You have to learn the syntax and little nuances. To actually write programs, you see what they do and determine how to use MATLAB to solve your problems. You actually have to use MATLAB. We are going to be using MATLAB. We have homeworks that require you to use MATLAB. A programming language is a tool a programmer uses to express logic for a computer to implement, which is defined by your computer grammar, which is your syntax and its vocabulary. And here is a link that you can use to download download MATLAB from Temple University's IT website. It is available to all engineering students. So, more important than the computing concepts inherent in all computer language is the ability to use these concepts as tools to solve a problem. So before we even start to program, you have to develop an idea of how to solve the problem we have before us. So after we go through the basics of how this program works, we're actually going to look at how to solve a problem. We're going to figure out how to go from the data, what you have and what you can do with the data, to how you can find the answer to get to the answer. The process in the middle is what we do as engineers and through all of our coursework, is trying to figure out how do we get from what do we know to what do we need. At the simplistic level, MATLAB is basically a calculator on steroids. The name MATLAB is actually a contraction of matrix and laboratory, so it should come at no surprise as MATLAB actually does everything in terms of a matrix. Some true coders will tell you this is not a coding language, but whatever. It was developed for engineers to create, manipulate, and visualize matrices, which are rectangular arrays of numerical values. So it's very based in matrices. So we're going to look more into that as we go forward. So this is what the MATLAB interface looks like. It has a command window which shows both the prompts you type and the output of a program. You can just type directly into your command window. When you hit enter, you'll get a result. So your workspace is a list of variables and their type and their value. So if you run a code and the answer is not giving you what you want, you might want to look into your variable and what's actually being stored there. The current folder lists all the MATLAB files in your current folder. Your layout, you can reset the layout to however you want. Some layouts work better for laptops versus large PCs. I have my editor window, which we'll get to in a little bit, docked with my command window and tabs. So in the bottom left of MATLAB, you will always see its status. It will show the status of a program, if it's ready to run, if it's busy. If it says busy and you want to stop the program, you can always just hit Control-C. If you're working in the command window, you can hit the up arrow to scroll through your previous commands typed into your window. Some useful function is docxx will bring up whatever information about that variable. CLC clears everything in your command window, which will give you a new clean space to work with. Clear, on the other hand, erases all the variables. So CLC just clears up your command window. Clear actually erases variables from your workspace. These are two good commands to put in the beginning of all of your programs because you don't necessarily want old information sitting around in your variables messing with your solutions. So this is actually what the editor interface looks like. In this case, you can see that we have the editor docked above the command window, so we can write our M files up here, and when we execute them, the results show up down here. So at the end of your editor string, you see your actual file name, which is also listed in your current folder. We're going to go over more of the requirements for a file name in MATLAB. One of the big ones is that it cannot have spaces. The bar above the editor shows you what file where your file is located on your computer. MATLAB works out of a single folder, or you have to add a separate folder to your path if you are opening a file that is outside of the folder you are currently in. If you want to create a new editor, you just click Create New. There's an M file. There's also live files that kind of combine the command window and the M file into one. Again, this is showing you a docked interface where the editor is docked above the command window. In my version of MATLAB, I typically have them tabbed on top of each other. You can move windows into any configuration. The little arrow next to the X for your editor window allows you to undock this window and put it into a separate main interface. So you could have your command window in one window and your editor another. You can split screen them. You can put them on separate monitors. Lots to play around with. The big one here is run. You can run the program by clicking the run button. I also advise if you hit F5, it actually saves and runs your program. You have to make sure you save your program before you run it. There is a save and run option. And then if you were to ever need to publish one of your programs, you can actually publish your program to a PDF. If you are in the editor window, you can go to the Publish tab and select the Publish option by opening the drop-down menu and choosing Edit Publishing Options. You can publish as an HTML, PDF. You can change your output to PDF. You want evaluate code set to true, because otherwise you're just going to have a code that has no answers in it, and that's not very useful for submitting a homework assignment of here's what I wrote. Now you want here's what I wrote and here's the output that it gives. And then once you click publish, you will get a file that's stored to the folder that is currently set. It's the HTML folder, but it has PDFs in it. So some useful functions in MATLAB. Again, CLC clears the command window. Clear clears all your variables in your workspace. Close will close all figures. Putting a semicolon after a line of code will not display the result in the operation in the command window. So if you have a lot of steps to a problem that you don't necessarily want to print, you want to suppress them with a semicolon. Help displays basic information about the function in the command window. Doc opens the documentation browser to give you all the documentation MATLAB has on a specific function. Save stores a copy of the workspace variables and other media on the hard drive or other media, so you can save variables, figures, and load get stored variables from your computer to the workspace. So if we look at the help function a little bit more, say I want to use the square root function, which in MATLAB is sqrt. So if I type help sqrt, it's going to tell me that sqrt is the square root, and sqrt of x is the square root of the element x. Complex results are produced if x is not positive. It's telling me also to see different functions, and then it gives me a link to the reference page. If I was to type doc square root, it would open the documentation page, which is going to tell me all the documentation about the square root, which you can also find by basically by Googling any function in MATLAB, or if you want to do something in MATLAB that you're not 100% sure how to do and you Google it, you're probably going to be taken to the MATLAB help pages online where there's a community. It explains all of the functions, it gives examples. MATLAB has a large database of help. It also has an onboarding program called OnRamp that you can do to help get yourself started. MATLAB has different variables and data types. So variables are different than mathematical variables. So In math, a variable is typically an unknown for which you are trying to determine a value. In MATLAB, however, a variable is simply a label or a container that you're storing information in. And these variables are classified according to the type of information that they hold. So we have a numeric array. These include scalars, vectors, and matrices, and they contain only numbers. You can have a character array. These are text strings, where each character occupies one element. You can have a logical array that tells you if something is true or false, where 0 means false and 1 means true. We're going to go over this more in chapter 18 when we go over logic. You can have a cell array, which is a mixture of data types. You can have a structure array, which contains a mixture of data types, but your data is organized into named fields. A sparse array saves memory by only storing non-zero elements. It's not covered. And then you can have symbolic arrays, which allows you to do symbolic mathematics within MATLAB. Hopefully we will have time this semester to get to some symbolic language at the end of the semester. So basic data manipulation in MATLAB. So you're assigning values to variables. So for example, if I type in z is equal to x plus y, it simply means that I want to sum the values given to the variable x and y and store them as a result in the variable z. So x and y have to be defined before this calculation to occur. If they are not, an error statement is going to occur. Part of the frustration of MATLAB is also trying to figure out the errors that it gives you. It typically tells you why it can't do a certain calculation, and then you have to figure out, well, where is this error occurring? It tells you usually what line it's occurring in if you're using an M file. And then we have data typing. So a value is assigned a variable. When a value is assigned a variable, MATLAB determines the type of data storage depending on the type of data being stored. So for example, if I type A is equal to 42, it's going to store it as a numeric type double, which just has to do with the number of decimal places. If I say A is equal true, it's going to store it as a logical variable. If I say A is equal to ABC, I'm now storing a character string. So your variable A can be any type depending on what you actually store into it. So we're going to move into some variable basics. This includes remembering the naming rules for variables as well as files in MATLAB, and understanding the use of how the equal sign acts as the assignment operator. There are some rules we have to follow. So the naming rules for MATLAB are all names must consist of only letters, numbers, and the underscore character. To get the underscore, you hold shift and hit the hyphen. Names can only begin with alphabetic letters, no numbers or special characters. So you can't have a variable that's 2b. You can have b2 but not 2b. Names cannot be longer than 63 characters, which if you have a variable name that is 63 characters long, I suggest you shorten it because you do not want to type out all 63 characters every single time. It's a bit excessive. Names in MATLAB are case sensitive, so frog with a capital F and frog with a lowercase f are different. And names cannot have the same name as any other identifier. So you don't want to create a variable that has the same name as a program name, a function name, a built-in function, a built-in constant, or a reserved word, because MATLAB's order of execution may prevent the program from finding the correct item. MATLAB has an order to which it checks variables, and if you rename a variable that already exists, for example, if I create a variable called pi, even though pi already exists, I'm basically going to overwrite the existing definition of pi and not be able to use my built-in function. A common error in naming variables or other things in MATLAB, which includes files or functions, is to include a space character. MATLAB names cannot have a space in them. To indicate a space, you should use the underscore. The rules apply to any named items, not just variables. So again, this goes for file names and function names. So always try to choose names that have meaning within context of the program. For example, if you are trying to create a variable that contains the diameter of a bolt, for example, name it bolt diam instead of x1, q, or d. This is actually something that I have to work on. I've it's been pointed out by several students that some of my codes aren't exactly helpful to them because I use variable names like K or KK. Again, coding becomes very personal, so you ideally want to make it as you usually want to make it as easy as it possibly can be for somebody else to look at your code and understand what's going on. So how do I assign things to variables? To assign things to variables, you're going to use the assignment operator, which is just the equal sign. It's going to tell the computer to put a value into a variable. MATLAB uses the equal sign. There are other ones, but they are for advanced topics. So in math, a equals a plus 1 means there's two solutions for a. We're actually trying to solve for the value of a. Well, in programming in a MATLAB, all it means is add 1 to whatever is in variable a and then place the result back into variable a. So you can think of the equal sign not so much as an equal sign, but as instead think of it as is assign the value of. So we're assigning the value of a plus 1 into the variable a. Data transfer is always right to left, so the left must be a variable. The variables on the right also must be predefined. If they are not predefined, you're going to generate an error. So you can save and restore values. So variables can be stored as text files. To save your variables in a workspace, you simply just type save and then your file name .mat. To load variables in your workspace, you just type load and the file name .mat. .mat is a MATLAB variable. You can also export as CSV and text files to be used in other programs such as Excel. We're going to actually go into how to transfer Excel data to MATLAB a little later. This will overwrite any variables that already exist that have the same name. So if you're loading in data and you've already been running a program, you are going to overwrite any variables that already exist. To save or load selected variables, you would do save and you have your file name, which is telling MATLAB which file to look for, and then the variable names. And the same goes for load. So let's look at some numeric types and scalars. So we want to create numeric scalars in MATLAB, we want to perform basic scalar operations, and we want to write mathematical expressions using scalar functions. So numerical data is information consisting of one or more numbers. In MATLAB, there are several different types of numerical data. We have integers and non-integers, which are floating point numbers. They are categorized based on how many values are stored and how they are arranged. So we have scalars, vectors, and matrices. So we're going to start with scalars. A scalar is simply a single numeric value. So 7 minus 32.12, 2.7 is 7 times 1015, or 2.4 plus 3.92i. All of these are just numbers, even if they are complex. In MATLAB, a scalar is actually considered a 1-by-1 matrix because, again, MATLAB works exclusively with matrices. So you want to simply use the assignment operator equal sign to place your desired value into a variable. So if I wanted to create a variable named num and I want it to be 34, I want to type num equals 34. That's going to store the value of 34 into my variable num. I can do the same with storing the value 62 into age. I can say root 1 is equal to my complex root there. I can have a big number where if I want to use raise it to a power in scientific notation, MATLAB understands that. The E can be lowercase or capital. And I can also do the same with tiny numbers. So these are scalars. There also are some predefined constants in MATLAB, which are variable names that you should avoid. For example, pi. If you type pi into MATLAB, you're going to get the pi to 15 decimal places. I is the square root of -1. J is also the square root of -1, and I and F is infinity. Defining variables that have these names will overwrite them. A big one is I overwrite I and J all the time when I do loops, which I should probably come up with better variables so I don't accidentally need the square root of a negative number in my program. So how do we do calculations with scalars? Well, most scalar calculations work the same in MATLAB as they do in your calculator. For example, if I define a variable dpm and I say dpm is equal to 39 divided by 19 plus 5 times 3, it's going to follow the standard order of operations, and I'm going to get an answer of 17. If I define a variable RTP and I define it to be 3 squared plus 1, well, 3 squared is 9 plus 1 is 10, and my variable is going to contain the value 10. So it follows the same order of operations for the most part that you are already used to. Some useful numeric functions. There's no time in any course for me to teach you every function that exists in MATLAB. Well, we have the round function, which will round to decimal places or significant figures. We have ceil, which rounds towards positive infinity, floor, which rounds to negative infinity, fix, which will round towards 0. You have the square root, we have the nth root, we have real, imaginary. You have all of your trig functions. You have sine d, which is sine in degrees, which is very useful. You have your exponential function, which is just exp. You also have a function called degrees to rad, which converts degrees to radians, another useful function in engineering. Log is a natural logarithm, and log 10 is the base 10 logarithm. So that's something to remember in MATLAB. ln, which is your natural logarithm, is actually just log. You can look up any more functions in MATLAB that you want by searching help and typing a function name or Googling. So how can we display numbers? The default numeric display is 4 decimal places. You can show 15 decimal places by using format long. So for example, if I do 100 times pi, I'm going to get 3.14.1593, which displays 4 decimal places. If I do pi divided by 1,000, I'm only going to get 0.0031. Whereas if I do pi divided by 10,000, I'm going to get 3.1416 e to the 4. So I have a number here that it's 9 characters long, but doesn't have a decimal place in it, so it's going to display all the characters up till 9. However, if I go to a 10th character, it's going to display it in scientific notation because it's run out of characters to display. You can only display 9 characters for an answer. So that's it for this lecture on scalars and basic MATLAB skills. I encourage you all to start the MATLAB on-ramp and begin working on some homework problems and actually opening MATLAB and messing around with it. In the next lecture, we are going to go over vectors.